when we look at our triangle now, we should be able to figure out our missing two holes. I can see from the triangle sine theta, since that's y over r, sine theta is y over r, that's going to be square root 1 minus x squared over 1. And so sine theta is just going to be the square root of 1 minus x squared. As for cosine theta, maybe you already knew this. You can tell from this step up here. But cosine theta is x over r, x over 1, cosine theta is x. And so I've got this complicated looking algebra equation, but I should be able to solve that. Let's try to clean this up. X equals, we have square root of 1 minus x squared times the square root of 3 plus x all over 2. At which point, I'm going to try and get rid of the fraction. I'm going to multiply both sides by 2 just to cancel out that fraction. I've got 2x equals square root 1 minus x squared times the square root of 3 plus x. I have like terms. I'm going to subtract this x. X equals square root 1 minus x squared times the square root of 3. Let's get rid of the square root. I'm going to square both sides. X squared equals 1 minus x squared times 3. Now this is the step, we've just squared both sides, and so this is the step where you have to really think about it and be careful. But when we square both sides, we've added extra solutions in there, extraneous solutions. Let's continue solving though. Let's distribute the 3. Combine like terms. And 4x squared equals 3. Divide by 4. So x squared equals 3/4. And then at last I'm going to take the square root on both sides. Actually, that's a plus or minus root because I'm going to get plus or minus square root of 3 over 2. You're going to get square root of 3 over 2 and negative square root of 3 over 2. But keep in mind, when I squared both sides, I created an extra solution. So it's going to turn out that one of those numbers isn't going to work. Okay? One of those numbers isn't going to work. So how do I check? I've got to go back to my original equation and plug in those values. So let's use a calculator. And let's plug in. I would have inverse sine of the square root of 3 divided by 2. Let's check that one first. Minus inverse cosine of the square root of 3 over 2. And hopefully that equals pi over 6. That's what it's supposed to do. So let's see what pi over 6 is. Pi over 6. Same thing. Okay, so that's good. That's good news. That means that square root of 3 over 2 works. That's actually going to be a solution. And I suspect that negative square root of 3 over 2 isn't going to work, but let's just check it out. Okay, let's check it out. We would have inverse sine of negative square root 3 over 2 minus inverse cosine negative square root 3 over 2. And again, that's supposed to equal pi over 6. That's definitely not the same thing as pi over 6. And so, yeah, I can tell this one doesn't work. So we've got our solution. There's only one solution. X equals the square root of 3 over 2. Now, that's a tough problem. But I kind of skipped over the toughest part, which was how did we know that picture was in the first quadrant. And so now I'm going to show you how we figured out and how we would know, because when you do one of these problems, you really are going to have to know that. And so go back to, I guess it would be this step right here that's in green. Okay? It said inverse sine of x equals inverse cosine of x plus pi over 6. Okay? So let's kind of start with that. We know from the definitions of our inverses, we know the range of inverse sine is in between pi over 2 and negative pi over 2. We know that. But because of this green statement, I can do a substitution, and I'm going to plug that in. And so plug in that inverse cosine of x plus pi over 6. And we could say that that's in between pi over 2 and negative pi over 2. I just did a substitution, that's all. I want to kind of isolate my inverse cosine, so I'm going to subtract pi over 6 just to get inverse cosine by itself. That's what I want. And I need to get a common denominator. You've got 3 pi over 6. Negative 3 pi over 6 minus pi over 6 is negative 4 pi over 6. But that's negative 2 pi over 3. So let's just go ahead and reduce. And over here, you've got 3 pi over 6 minus pi over 6 is 2 pi over 6. And that's pi over 3. So we just got a new statement that says inverse cosine x has to be in between negative 2 pi over 3 and positive pi over 3. But that doesn't really make sense totally because we know from our definitions that cosine is in between 0 and pi. That's where its range, that's inverse cosine's range is from 0 to pi. And so what that means is you can't have this negative value, you can't have any negative values. And so essentially that means inverse cosine in this example is wedged in between 0 and pi over 3. And so if you think about where that is, pi over 3 is like a 60. I know we're better at picturing degrees. Pi over 3 is right here. And so our angle, which we didn't call it x, we called it theta. Our angle is somewhere in between 0 and pi over 3. Well, that's the first quadrant. And so we kind of, earlier in this problem, we kind of just assumed that that picture was in the first quadrant. That'll only take you so far. If you try to do that, you're not going to get them all right. You might get one right, you might get the next one wrong. You really can't just guess what quadrant it is. If you really want to know these and really want to do these right, you're going to have to figure out what quadrant it is. And I know that's kind of tough, but that's what you're going to have to do.